Welcome, curious minds and sleepy thinkers. You've found a soft place to land tonight, a quiet harbor where the questions are as vast as the night sky, and the pace is slow enough to walk alongside your dreams. There is no need to rush here. Let the weight of the day dissolve into the background, like distant city lights blurring into a gentle haze. We are here simply to wonder, to drift on a slow current of thought, and to listen to the whispers that come from the deepest, most silent corners of our universe. Tonight, let us gently explore a question that lies at the very heart of our own existence. It is not a question of complex physics or mathematics, but one of storytelling and memory. What if we could read a story written before the Earth was born? What if we could hold in our hand a single physical word from the first chapter of our solar system? This is the journey we embark on now, a gentle tiptoe into the profound mystery of our own origins, guided by a messenger sent out into the great dark. But do not worry about the scale of it all. This is not a lecture hall, and there will be no test. Think of this not as a lesson, but as a journey. Imagine we are sitting by a quiet, cosmic shoreline, watching the tide of space and time ebb and flow. We will simply observe the messages that wash ashore these ancient relics from a long-forgotten ocean. We will pick one up, feel its texture, and wonder about the journey it has taken to find its way to us here now. This is a story of patience, of listening, and of reaching out a hand across an impossible distance just to feel a connection to our own beginning. Let's begin not with the roar of a rocket, but with the silence that precedes it. Before any mission is launched, before any metal is forged, there is a quiet moment of human curiosity, a question that sparks in the mind like a single distant star coming into view. For millennia, we have looked up at the night sky and seen points of light. We named them, charted their paths, and built stories around their steady celestial dance. We saw gods and heroes, monsters and myths. But as our tools for seeing grew sharper, the myths gave way to a different kind of story, one even more wondrous. We learned that those points of light were worlds, suns, and galaxies. We learned that the space between them was not empty, but filled with a history so deep it defies imagination. And scattered throughout this history, like seeds on the wind, are the asteroids. For so long we saw them as little more than rubble, the leftover debris from the grand construction of the planets. We thought of them as cosmic footnotes, insignificant rocks cluttering the elegant orbits of their larger siblings. But what if that perspective was incomplete? What if the most profound stories are not written in the grand sweeping narratives of planets, but in the quiet, humble prose of the small things that were left behind? Imagine for a moment the birth of our solar system some 4.5 billion years ago. It was not the neat, orderly place we know today. It was a vast, swirling cloud of gas and dust, a cosmic nursery filled with infinite potential. Gravity, the silent sculptor of the universe, began to pull this material together. Clumps formed, growing larger and larger. At the center, the pressure grew so immense that a star ignited our sun. Around it, the remaining dust and gas continued to coalesce, forming the planets. Great worlds like Jupiter and Saturn, rocky spheres like Earth and Mars. It was a time of immense creation, of violent collisions, and of magnificent chaotic beauty. But not all of the material was used up. In the great rush to build worlds, some of the original building blocks were left scattered. They were too small to become planets, too isolated to be swept up into the gravity of a larger neighbor. They were simply left. These are the asteroids. They are not just rocks. They are pristine artifacts from that primordial time. While the planets were changing, melting, and reforming under the immense heat and pressure of their own formation, these little asteroids remained largely untouched. They were flash-frozen in time, preserving the original chemical recipe of the ancient solar nebula. They are time capsules. Not capsules we have built and sent out, but capsules that have been waiting for us, drifting silently in the dark for billions of years. They hold the chemical fingerprints of the very stardust that would eventually form our world, our oceans, our atmosphere, and even ourselves. They are like unsent letters from the dawn of time, written in a chemical language we are only just beginning to learn how to read. To study them is to perform a kind of cosmic archaeology, digging not into the soil of the earth, but into the very soil of time itself. And so the quiet question that began this journey becomes a mission. How do we read one of these letters? How do we open one of these time capsules without contaminating its ancient message? We cannot simply wait for them to fall to Earth. When an asteroid enters our atmosphere, it becomes a meteorite, and its fiery descent changes it. The intense heat alters its delicate chemistry, and upon landing, it is immediately exposed to the oxygen and water of our world. The original message becomes blurred like a letter left out in the rain. To read the pristine text, we must go to the source. We must travel across hundreds of millions of kilometers of space, find one of these tiny ancient worlds, and gently take a sample. This is the beautiful, audacious idea behind the OSIRIS-REx mission. The name itself is a kind of poem, a summary of its grand ambition. Let's drift through it piece by piece. Origins. This is the heart of it all. The mission is a quest to understand our own beginnings. Where did the building blocks of planets come from? Where did the water in our oceans originate? And perhaps the most profound question of all, where did the organic molecules, the chemical precursors to life, first appear? These asteroids, these carbon-rich time capsules, might just hold the answers. They may have been the cosmic couriers that delivered water and organic material to the young Earth, seeding our world with the potential for life. Spectral interpretation. This is how we begin to read the letter before we even open it. From a distance, the spacecraft can analyze the sunlight that reflects off the asteroid's surface. Different materials absorb and reflect light in unique ways, creating a sort of chemical signature or spectrum. By studying this light, scientists can create a map of the asteroid's surface, identifying areas rich in carbon or areas that show the telltale signs of water locked away in clay minerals. It is a way of seeing the invisible, of understanding the asteroid's composition from afar. Resource identification. While the primary goal is scientific, there is a practical curiosity as well. What are these asteroids made of? Could they one day be a source of resources for future generations of explorers? This is a question for a distant future, but the first step to answering it is to understand what is there. This part of the mission is about taking inventory, about creating a catalog of the materials that make up our cosmic neighborhood. Security. This speaks to our relationship with these celestial neighbors. Some asteroids have orbits that bring them close to Earth. Understanding their size, composition, and trajectory is crucial for predicting their future paths. By studying a near-Earth asteroid like Bennu up close, we can refine our models and better understand the dynamics of these objects. It is a way of ensuring our own safety, of being a responsible and aware inhabitant of a dynamic solar system. It is about knowing our neighbors. And finally, regolith explore. Regolith is the word for the loose layer of dust, soil, and broken rock that covers the surface of a solid celestial body. It is the skin of a world. The mission is at its core an exploration of this ancient soil. The plan is not just to look, but to touch, to extend a robotic arm and collect a small piece of this primordial ground, a handful of 4.5 billion-year-old dust, and bring it home. So the vessel for this grand quest, OSIRIS-REx, is more than just a machine. It is an ambassador. It is an extension of our own curiosity, our own hands reaching out across the void. It was not sent to conquer or to claim, but to listen, to observe, and to receive a gift that has been waiting for billions of years. The destination for this ambassador was a carefully chosen one, a small asteroid named Bennu. Bennu is not just any rock. It was selected from over 500,000 known asteroids for a very specific set of reasons. It is relatively close, making the journey feasible within a reasonable time frame. It is a carbonaceous asteroid, meaning it is rich in carbon, the fundamental element of life as we know it. Its size and rotation speed made it a viable target for a spacecraft to orbit and approach. But perhaps the most poetic reason for its selection is its age and its pristine nature. Bennu is believed to be a fragment of a much larger asteroid, a relic from the solar system's chaotic youth. It has been preserved in the cold vacuum of space, a tiny dark world holding on to the secrets of its birth. To visit Bennu is to visit a museum of the solar system, a place where the exhibits are not behind glass, but are the very ground beneath your feet. The name Bennu itself comes from an ancient Egyptian deity, a bird associated with the sun creation and rebirth. It was a fitting name chosen by a third-grade student in a contest. He thought the spacecraft, with its long sampling arm extended, looked like the neck of a heron, a bird often used to depict Bennu. And so the spacecraft and the asteroid became linked in a story that spans from ancient mythology to modern space exploration, a testament to our enduring need to find meaning and narrative in the cosmos. Imagine then this quiet emissary, OSIRIS-REx, finally leaving our world. It rises on a pillar of fire, a brief and violent moment that gives way to years of silent, graceful coasting. It escapes the pull of Earth's gravity and begins its long looping dance through the solar system. It is a journey of immense patience. There is no air to rush past, no scenery to watch fly by. There is only the vast, silent blackness, punctuated by the unwavering light of the distant sun and the pinpricks of even more distant stars. The spacecraft is not simply flying in a straight line. It is following a carefully calculated path, an invisible road through the gravitational landscape of the solar system. It uses the Earth's own gravity for a boost, a cosmic slingshot, to hurl it deeper into space. It is a journey that requires a profound understanding of the universe's underlying rules, the celestial mechanics that govern the motion of everything from a speck of dust to a giant planet. This is the quiet prelude to our story. It is the deep breath before the discovery. It is the journey outward, away from the familiar blue and white marble of our home and into the profound and ancient darkness. It is a journey fueled by a simple, powerful question. What is our story? To find the answer, we must first travel back in time, not with a machine of gears and dials, but with a vessel designed to catch a whisper from the dawn of our own world, carried on the silent solar wind. In the coming moments, we will travel with it, leaving the known behind and drifting slowly, patiently toward a small spinning diamond in the dark, an ancient messenger named Bennu. Let us drift now away from the solid ground of intention and into the vast, silent ocean of the journey itself. The pillar of fire that lifted our gentle messenger from its earthly cradle was but a momentary roar, a fierce and fleeting breath that pushed it beyond the blue veil of our atmosphere. Once that breath was spent, a profound and unending quiet took its place. This is where the true voyage begins, not in sound and fury, but in a slow 2-year exhalation into the deep. Imagine the spacecraft OSIRIS-REx, now alone. The Earth, its home, begins to shrink behind it. At first, it is a glorious swirling marble of blue, white, and green, a vibrant testament to life in the sterile expanse. But as the days turn into weeks, this familiar world recedes. It becomes a crescent, then a bright blue-tinged star, a beacon of impossible warmth and color in the monochrome black. Soon, it is just another point of light, brighter than the others perhaps, but still just one among countless distant suns. This slow visual departure is the first lesson of the journey, the lesson of scale. Our world, which contains all of our noise, all of our triumphs and sorrows, is rendered into a single quiet speck by the simple act of moving away from it. The spacecraft is now a seed cast upon the solar wind. It is not traveling on a highway paved with light, but rather drifting on invisible currents of gravity. The sun, the colossal heart of our solar system, dictates the shape of this journey. Its immense gravitational pull creates a landscape of invisible hills and valleys, and OSIRIS-REx must navigate this terrain with exquisite precision. It is less like a ship powering through the waves and more like a sailboat catching the unseen force of gravity to guide its path. Its solar panels, outstretched like wings, are not for propulsion, but for life. They drink in the sunlight, converting the ancient photons that have traveled millions of kilometers into the electricity that keeps its mind awake and its heart beating. For long stretches of this 2-year drift, the spacecraft is a sleeping traveler. To conserve its precious energy, mission controllers on Earth place it into a state of hibernation. Its higher functions are powered down, its instruments are quieted, and it enters a state of deep electronic slumber. It is a solitary monk in a silent cosmic monastery, its journey a long and patient meditation. The only sign of life is a faint periodic heartbeat, a simple radio signal sent back to Earth, a whisper across the void that says, "All is well. I am still here. I am still on my way." On Earth, a team of dedicated human beings watches over this sleeping messenger. They are the keepers of the flame, the celestial navigators of this modern age of exploration. From their control rooms filled with screens displaying endless streams of data, they track its silent progress. They are like gardeners tending to a single precious plant in a vast and distant desert. Their commands are not shouted but whispered. A tiny pulse of radio waves traveling at the speed of light takes minutes, then tens of minutes to cross the growing expanse. The command might be to make a minuscule adjustment to its trajectory, to fire a thruster for just a fraction of a second. This is not a brute force correction. It is a gentle nudge, like a breath of air on a floating feather, ensuring the spacecraft stays true to its invisible gravitational river. Think of the patience required to send a message and then wait in silence for the reply that confirms it has been received and executed. It is a conversation conducted across an ocean of time and space, a dialogue measured in the steady, unchangeable speed of light. It is an act of profound trust, both in the laws of physics and in the resilience of the little craft sailing through the dark. The path it follows is not a straight line. A straight line is often the most inefficient way to travel in space. Instead, the journey is a long, graceful arc, a piece of a celestial dance choreographed billions of years ago by the formation of the solar system itself. The primary dance partner in this first phase of the journey is the very world the spacecraft left behind Earth. About a year into its mission, after traveling hundreds of millions of kilometers in a wide, sweeping orbit around the Sun, OSIRIS-REx returns for a fleeting visit to its home. This is not a homecoming. It is a critical maneuver, a moment of gravitational poetry known as a gravity assist. The spacecraft dips back towards Earth, accelerating as it falls into our planet's gravity well. It skims over the Antarctic ice, a silent shadow, passing 17,000 kilometers above the surface. For a brief period, it is once again close enough to see the familiar continents and oceans. It is a moment of connection, a final swift wave goodbye. But it is a wave with a purpose. As it swings around the planet, it does not use any fuel. Instead, it steals a tiny amount of Earth's orbital energy. Imagine a child on a swing set. As they reach the bottom of their arc, they pump their legs, adding energy to go higher. In this cosmic version, Earth is the unmoving anchor and the spacecraft is the swing. By approaching the planet from behind in its orbit, the spacecraft is caught and flung forward like a stone from a slingshot. This graceful, silent maneuver increases its speed by thousands of kilometers per hour, bending its trajectory and setting it on the correct path to intercept Bennu. It is a perfect example of cosmic efficiency, of using the universe's own immense power to achieve our goals. It is a dance where our planet leads and our tiny messenger follows its steps perfectly before being spun away deeper into the solar system. With that final push from home, the longest and quietest part of the journey begins. The spacecraft is now truly in the deep, its path irrevocably set toward its distant target. The silence out here is deeper than any earthly quiet. It is not just the absence of sound waves which cannot travel in a vacuum. It is the absence of everything. There is no air, no weather, no up or down. There is only the constant, unwavering presence of the sun to one side and the infinite, star-dusted blackness on all the others. The spacecraft's internal gyroscopes and star trackers are its only sense of direction, its internal compass in the boundless void. Days bleed into weeks, weeks into months. The passage of time is measured not by clocks, but by the slow, stately rotation of the spacecraft, turning itself to keep its instruments cool and its solar panels illuminated. It is measured by the changing constellations, the slow shifting of the stellar backdrop as it moves millions of kilometers every single day. The Earth is now so distant that it has merged with the background stars, identifiable only by its faint blue hue and its known coordinates. The connection to home is now purely electronic, a fragile thread of radio waves stretching across an almost unimaginable gulf. During this long drift, we can allow ourselves to wonder about the nature of such a solitary existence. Does the spacecraft in its electronic slumber dream of its destination? Of course not. It is a machine of logic and circuits, but we, its creators, can dream for it. We can imagine it as a vessel of pure potential, a carrier of human hope and curiosity. It carries with it the questions of countless scientists, the dreams of engineers, and the simple, profound wonder of every person who has ever looked up at the night sky and felt a sense of awe. This journey is a powerful metaphor for any long and patient endeavor. It teaches us that most great achievements are not the result of a single heroic leap, but of countless small, steady steps taken over a great deal of time. It is a testament to the power of persistence, of staying true to a course, even when the destination is too far away to see. The spacecraft does not worry about the distance. It does not feel impatient. It simply follows its path, 1 kilometer at a time, trusting in the laws of physics and the careful guidance of its distant creators. As the second year of its journey nears its end, a subtle change begins. The long slumber is over. One by one, the spacecraft's systems are brought back online. Its scientific instruments are warmed up, tested, and calibrated. Its electronic eyes are opened, and they begin to peer ahead into the darkness. The messenger is awakening, for it is nearing its destination. At first, Bennu is nothing more than a faint speck of light, indistinguishable from the thousands of other asteroids and distant stars in its field of view. But unlike the stars, this speck is moving, and it is growing. Day by day, as OSIRIS-REx closes the final millions of kilometers, the speck becomes a dot. The dot resolves into a tiny pixelated shape. The long abstract journey is about to become a concrete, tangible encounter. The 2 years of silent, patient drifting are culminating in this moment of arrival. The silence is about to be broken, not by sound, but by data, by images, by the first trickle of information from this unknown world. The letter, which has been traveling for 4.5 billion years, is about to be delivered, and our messenger, OSIRIS-REx, having crossed the vast empty ocean of the inner solar system, has finally arrived at its shore. It slows down, not with screaming retro rockets, but with tiny, precise puffs from its thrusters, gently braking over weeks and months to match the speed of the tiny world it has traveled so far to meet. The long dance is almost over, and a new one, a dance of close observation, is about to begin. The sleeping traveler is now wide awake, its gaze fixed upon the spinning diamond in the dark, ready to begin reading its ancient story. The long silent drift is over. Our patient messenger, OSIRIS-REx, has arrived. But arrival in the cosmic sense is not a singular moment, not a docking at a celestial port. It is a slow, delicate process of acquaintance, a cautious dance of approach. Imagine approaching a wild, sleeping creature you do not wish to startle. You would not rush forward. You would circle, watch its breathing, and learn its nature from a safe distance. So it is with the spacecraft and Bennu. For weeks, OSIRIS-REx performs a series of careful arching flybys, like a moth, circling a distant dark flame. It maps the space around the asteroid, tasting its gravitational influence. This is a gravity so faint, it is almost non-existent. Bennu, at only 500 meters in diameter, is a world with the gravitational pull less than 100,000th of Earth's. If you could stand on its surface, a single gentle jump would send you drifting off into space, never to return. To orbit such an object is a feat of incredible precision, like trying to balance a needle on its point. The slightest error, a thruster pulse a fraction of a second too long, and the spacecraft would overshoot its mark, sailing past its destination and back into the lonely expanse. During this cautious approach, the spacecraft's eyes are wide open, and the images they gather are sent on their long journey back to Earth. The faint speck of light that had grown into a dot now begins to resolve into something more. At first, it is a blurry collection of pixels, a smudge of gray against the perfect black. But with each passing day as the distance closes, the pixels sharpen. The smudge gains a boundary. The boundary gains a texture. And then a shape emerges. A wave of quiet astonishment ripples through the control rooms on Earth. For years, scientists had a model of what Bennu would look like. Using powerful radar from Earth, they had bounced signals off the asteroid, creating a rough, ghostly image of its form. The prediction was for a relatively round, slightly lumpy sphere, the classic image of a rubble pile asteroid, a loose aggregation of rocks held together by gravity. They were expecting a potato, perhaps, or a well-worn stone from a cosmic riverbed. But the universe, as it so often does, had a more elegant surprise in store. The reality that bloomed on the screens was far more striking, more geometric, more intentional. Bennu was not a lumpy sphere. It was a diamond. It was a spinning top seemingly crafted by a celestial artisan, with a smooth, sharp taper at its poles and a thick, pronounced ridge bulging around its equator. It was a world of startling symmetry, a shape both simple and profoundly strange. The ghostly radar images had captured the essence, but they had missed the poetry. This was not just a rock. It was a sculpture shaped by forces we are only just beginning to fully comprehend. This is the magic of exploration. It is the moment when a set of coordinates, a target in a database, transforms into a place. Bennu was no longer an abstract concept. It was a world with a character, with features, with a personality written in its very form. The scientists who had studied it for years as a collection of data points now found themselves staring at a portrait, and the face they saw was more intricate and fascinating than they had dared to imagine. So the first great question posed by this first sight was why this particular beautiful shape? The answer, scientists believe, lies in a delicate and patient process, a force so gentle it is almost imperceptible, yet so persistent, it can reshape worlds over millions of years. This force has a name, the Yarkovsky-O'Keefe-Radzievsky-Paddock effect, or YAOP for short. But its name belies the simple elegance of its mechanism. Let's imagine it this way. Sunlight, which we experience as warmth and light, is actually made of a ceaseless stream of tiny energy packets called photons. Each photon has no mass, but it has momentum. When a photon strikes a surface, it gives it a tiny, tiny push. On Earth, this push is utterly insignificant, lost in the overwhelming forces of gravity and atmospheric pressure. But in the near-perfect vacuum of space, for an object as small and light as Bennu, these tiny pushes matter. Over eons, countless trillions of photons from the sun have rained down upon Bennu. If the asteroid were a perfect uniform sphere, these pushes would cancel each other out. But Bennu is not perfect. It has irregular features, slopes, and valleys. One side might absorb more heat and radiate it away, later creating a slightly stronger push in one direction. A protruding boulder might cast a shadow, altering the thermal properties of the surface beneath it. Think of it like a pinwheel, not in a gentle breeze, but in the gentlest possible rain of light. Over millions upon millions of years, the sum of all these infinitesimal uneven pushes has caused Bennu to spin, And not only to spin, but to spin faster and faster. A day on Bennu, the time it takes to complete one full rotation, is now just over 4 hours long, and it is gradually accelerating. It is being spun up by the patient, relentless pressure of sunlight itself. This ever-increasing spin is the key to its diamond shape. Imagine standing on the surface of this tiny, rapidly rotating world. You would feel a force pulling you outward, away from the center, the same centrifugal force that presses you into your seat on a fast-spinning carousel. For the loose dust and pebbles, the regolith on Bennu's surface, this force is a tangible thing. As the asteroid spins faster, this outward push becomes stronger. Gravity on Bennu is incredibly weak, so it doesn't take much for this centrifugal force to overcome it. Slowly, over immense timescales, this has caused a great migration. Loose material from the higher latitudes of the asteroid, from near its poles, has trickled and tumbled downhill toward the equator. But downhill on Bennu isn't toward the center of gravity. It's toward the place where the outward push is strongest. This material has piled up century after century, millennium after millennium, creating the thick, bulging ridge that gives Bennu its distinctive shape. It is a world that is actively shaping itself with its own motion. It is threatening to spin itself apart, and the evidence of that strain is written in the very bulge of its waistline. And the shape was not the only surprise. As the images grew clearer, a second more daunting revelation emerged. The surface was not the fine-grained, sandy landscape the team had hoped for. It was a chaotic jumble of boulders. Everywhere. The initial models, based on the thermal properties of the asteroid, had suggested a surface covered in much smaller particles, a landscape that would be relatively easy to sample. But the first photographs told a different story. Bennu was a world of rocks, not just pebbles and stones, but colossal boulders. Some were the size of houses, others as large as cars. The surface was a rugged, treacherous terrain, a celestial junk pile of staggering proportions. The smooth, sandy beaches the mission planners had hoped to find for their sampling attempt simply did not exist. Instead, the entire world looked like a freshly dynamited quarry. The task of finding a safe spot to land a spot just a few meters across, clear of hazardous rocks, suddenly seemed almost impossible. The beautiful spinning diamond was also a dragon's hoard of jagged stones. This is the dual nature of discovery. With every answer comes a new, more complex question. The elegant shape was a beautiful puzzle to solve, but the boulder-strewn surface was a formidable practical problem that threatened the very core of the mission. The team on Earth had to adapt. Their carefully laid plans, developed over years, had to be reevaluated in the face of this new rugged reality. Let us pause here for a moment in this first orbit around this new world. Let us float alongside OSIRIS-REx and simply gaze upon Bennu. It turns slowly beneath us, a dark jewel against the velvet of space. Sunlight catches the sharp edges of countless boulders, creating a complex interplay of light and shadow. It is a place of profound silence, but it is not static. It is a dynamic world, spinning itself faster, shifting its surface, holding within its core the 4.5 billion-year-old memories of the solar system's birth. The arrival was more than just a successful feat of navigation. It was a lesson in humility. It reminded us that no matter how sophisticated our models become, the universe will always retain the capacity to surprise us. And in that surprise, there is a deep and abiding joy. It is the joy of learning that reality is more creative, more complex, and more beautiful than our imagination had conceived. Bennu was not the simple rock we expected. It was a world of contradictions, an object of elegant geometric beauty that was also a chaotic and hazardous mess of rubble. With this first stunning portrait of Bennu captured, the mission transitioned into its next phase. The initial dance of approach was over. Now began the long, meticulous process of mapping, of getting to know every crater, every ridge, and every single one of those troublesome boulders. OSIRIS-REx settled into a stable orbit, forever tethered by a thread of gravity to this tiny spinning world. Its introduction was complete. Now the real exploration, the intimate study of this primordial place, was about to begin. The messenger had arrived, the letter was in sight, and the first word it had spoken was surprise. The spinning diamond, once a distant wondrous jewel, is now the entire world. For OSIRIS-REx, the initial awe of discovery has settled into the quiet, demanding work of intimacy. To truly know a world, you must learn its every feature, its every flaw, its every shadow. And so begins the period of mapping, a year-long meticulous survey that will transform this alien landscape into a familiar territory. The spacecraft is no longer just a visitor. It is now a cartographer, a poet of topography tasked with drawing the definitive portrait of this ancient rugged place. To orbit Bennu is to perform a continuous act of balance on a gravitational knife's edge. The sun's gentle but relentless pressure, the solar wind, is no longer a negligible force. It is a constant, gentle breeze that the spacecraft must perpetually brace against. Bennu's own gravity is not a smooth uniform field, but a lumpy, unpredictable one, shifting and changing with every mountain-sized boulder that rotates beneath the spacecraft. The mission controllers on Earth cannot simply place the spacecraft in a stable orbit and let it be. They must actively fly it every moment of every day, making tiny, constant adjustments. Imagine a hummingbird, its wings a blur of motion hovering with impossible stillness, just millimeters from a specific petal on a flower. It adjusts for every puff of wind, for the slight tremble of the stem, its entire being focused on maintaining its precise position. OSIRIS-REx is this hummingbird, and Bennu is the flower. Its orbits are not the simple, elegant ellipses we draw in textbooks. They are complex, looping, rosette-like patterns, bringing the spacecraft swooping down to within a single kilometer of the jagged surface before rising again. It is in these breathtakingly close passes that the world of boulders reveals its true, daunting character. The process of mapping is an act of extraordinary patience. The spacecraft's primary tools are light and data. A laser altimeter, an instrument that is essentially a hyper-accurate measuring stick made of light, begins its work. It sends down a pulse of laser light, which strikes the surface and bounces back. By measuring the precise time it takes for the light to make this round trip, it can calculate the distance to the ground with millimeter accuracy. It does this thousands of times per second, building a three-dimensional map of the world below one point of light at a time. Think of it as the universe's most patient sculptor. Working in reverse. Instead of adding clay to build a form, the laser is adding data points, gradually revealing the form that has existed for billions of years. It is a slow, painstaking process of discovery, like a blind person learning the intricate contours of a beloved's face through the gentle touch of their fingertips. Each data point is a touch, a moment of contact that builds into a complete and complex understanding. At the same time, the spacecraft's cameras are constantly gazing downward. They take thousands upon thousands of images, capturing the surface in stunning high-resolution detail. These are not mere snapshots. They are puzzle pieces. On Earth, powerful computers and a dedicated team of scientists stitch these images together, draping them over the three-dimensional skeleton created by the laser altimeter. The result is the most detailed high-resolution map ever created of any celestial body in our solar system. We now know the face of Bennu better than we know the deepest trenches of our own oceans. And what a face it is! The initial shock of the boulder-strewn surface deepens into a profound sense of wonder. This is not a solid world that has been battered and broken by impacts. This is something far stranger. Bennu is the very definition of a rubble pile asteroid. Let us try to truly understand what that means. Imagine a construction site. After a building has been demolished, you have a massive pile of broken concrete, twisted rebar, and dust. Now imagine if that pile were so large that its own minuscule gravity was just barely enough to hold it together in a roughly spherical shape. That is Bennu. It is not a single coherent object. It is a loose, porous collection of countless individual rocks, pebbles, and dust grains all resting gently against one another. It is held together not by chemical bonds or geologic pressure, but by the faintest of gravitational whispers. If you could plunge your hand into its surface, you might find more empty space than solid matter. It is a cosmic dust bunny, a celestial sponge. This fragile structure is the reason the surface is so chaotic. The boulders are not just sitting on the surface. In many ways, they are the surface. They are the primary components, and the finer grained material is just the dust that is settled in the gaps between them. The scale of these boulders is staggering. The team on Earth begins to give them informal names as they map them just to keep track. There is one they call Ben Saxum, the largest of all, a colossal rock as tall as a multi-story building. Others are named Rock and Simurgh. Mythical birds of immense size, fitting names for these giant stones that seem to have alighted on the surface. These are not just obstacles. They are geological features in their own right, mountains on a world no bigger than a small mountain on Earth. This new intimate knowledge of Bennu's landscape presented the mission team with a formidable challenge. The entire plan for collecting a sample was based on the assumption that they could find a safe, clear, relatively flat area. The original requirement was for a landing ellipse 50 meters in diameter, about the size of a tennis court, free of any significant hazards. After months of mapping, the terrifying conclusion was undeniable. No such place existed on Bennu. Not one. The entire world was a hazard zone. The beautiful spinning diamond was from the perspective of a fragile spacecraft, a field of razor-sharp spikes. The mission was at a crossroads. They had traveled for years, spent hundreds of millions of dollars, and successfully arrived at and mapped this ancient world. But the final, most crucial step, the collection of a sample, now seemed impossible. This is where the human element of the mission shines with its greatest brilliance. The team did not give up. They adapted. They threw out the old plans and began to invent new ones. They would have to accept a much higher level of risk. They would have to attempt a landing in a space far smaller than ever intended. The search began anew, this time for a much smaller safe haven. The target was no longer a tennis court, but a space the size of a few parking spots. Thousands of people, including hundreds of citizen scientists from the public who volunteered to help, began the painstaking work of examining every square meter of the new maps. They were searching for a needle in a haystack of boulders. They counted and measured every single rock that could pose a threat, rocks that could damage the sampling arm, rocks that could tip the spacecraft over, rocks whose slopes were too steep. It was a forensic investigation on a planetary scale. As the team grew more familiar with this world, they began to name its features officially. This is a deeply human act, a way of taming the alien by giving it familiar labels. They continued the theme of birds and creation myths from various cultures. Craters were named after mythological birds of the underworld, fitting for features blasted into this dark, carbonaceous rock. The chosen landing sites would eventually be named for birds, known for their grace and precision in flight. The sterile map of data points and elevations began to transform into a landscape with a sense of place. It had a geography, a history, and now a name. After more than a year of this intense, meticulous work of orbiting, mapping, and debating, the team finally narrowed the possibilities down to 4 candidate sites, 4 tiny potential sanctuaries in a world of chaos. They were named Osprey, Kingfisher, Nightingale, and Sandpiper. Each name was a whisper of hope, an invocation of the qualities the spacecraft itself would need to embody. An osprey can dive from a great height to snatch a fish from the water with unerring accuracy. A kingfisher hovers with perfect stability before its strike. A sandpiper navigates a shoreline littered with obstacles. And a nightingale, a bird of the twilight, is known for the beauty and precision of its song. These 4 sites were far from perfect. They were small, claustrophobic clearings surrounded by what the team began to call boulders of doom, rocks large enough to destroy the spacecraft if the landing was off by even a meter or 2. But they were the best that Bennu had to offer. They were tiny pockets of possibility in a landscape of impossibility. The long, quiet observational phase of the mission was now complete. The initial shock at Bennu's ruggedness had been channeled into a new daring plan. The map was drawn, the hazards were known, and the 4 potential safe harbors had been identified. The spacecraft had done its work as a cartographer. Now it had to prepare for its most difficult role, yet that of a gentle precision pilot. The next step was to choose one of these 4 tiny spots and begin the final heart-stopping rehearsals for the day it would reach out and touch the surface of this ancient, boulder-strewn world. The time for looking was over. The time for touching was about to begin. As our tireless cartographer, OSIRIS-REx, spent its long year painting a portrait of Bennu's rugged face, it was doing more than just mapping the hazards. It was listening. Not with microphones to a silent world, but with instruments designed to perceive the invisible language of light. The mission was not just about finding a safe path. It was about understanding the very soul of this ancient rock. And in the quiet data streams that flowed back to Earth, Bennu began to share a secret, a profound and unexpected memory of a past it could not possibly have lived itself. This secret was unlocked through a kind of seeing called spectroscopy. Imagine for a moment that every material in the universe has its own unique voice, its own musical chord. We cannot hear these chords with our ears, but we can see them with the right kind of eyes. When sunlight strikes the surface of Bennu, some of it is absorbed and some of it is reflected. The spacecraft's spectrometers are like a cosmic prism. They catch this reflected light and break it apart into its full spectrum, a rainbow far more complex than the one we see in our sky, extending into the invisible realms of infrared. By looking at which notes of light are missing, which wavelengths have been absorbed by the surface, scientists can identify the precise materials that are present. It is a way of determining the chemical composition from millions of kilometers away. Each mineral, each element, sings its own unique song of absorbed light. And as OSIRIS-REx orbited its spectrometers, listened to the song of Bennu, what they heard was an astonishing and beautiful chord, one that sent a wave of excitement through the scientific community. It was the clear, strong, unmistakable signature of water. Now this was not the signature of ice on the surface or liquid water flowing in rivers. Bennu is far too small and exposed for that. Any water in those forms would have vanished into the vacuum of space eons ago. No, this was a far more subtle and ancient kind of water. It was water that was chemically bound into the very structure of the rocks themselves. It was the signature of hydrated minerals, most notably clays. Think of it this way. Imagine wandering through the driest, most ancient desert on Earth and finding a vast deposit of petrified sea sponges. The sponges themselves are bone dry, hard as rock. There is no liquid water anywhere in sight. But the very existence of the sponges, their porous structure, is an undeniable testament to a different time. It is proof that this desert was once a seabed, that this arid landscape was once saturated with water. The clay minerals on Bennu are like those petrified sponges. They are the chemical fossils of a water-rich environment. Clays form when rock and water interact over long periods. The water seeps into the rock, altering its crystalline structure, trapping water molecules within it. To find these clays in such abundance all over Bennu's surface was to find an echo of a lost ocean, a ghost of water on a barren, airless world. This discovery presented a beautiful paradox. A tiny world like Bennu, with its whisper-faint gravity, could never have hosted liquid water. It could never have been the warm, wet environment needed to form these clays. So if the clays didn't form on Bennu, where did they come from? The answer was as profound as the discovery itself. They were inherited. Bennu was a messenger, carrying a story that was not its own. The evidence points to a magnificent and long-lost ancestor, a parent body. Scientists believe that Bennu is a fragment, a tiny piece, of what was once a much, much larger world that existed in the early chaotic days of our solar system. This parent body might have been a protoplanet, a world hundreds of kilometers in diameter, or at least a very large asteroid. Let us try to imagine this lost world. It would have been large enough for its own formation and the decay of radioactive elements within its core to generate significant heat. It would have been a world of rock and ice, a mixture of the raw ingredients of the solar system. In its warm interior, the ice would have melted, creating a vast system of liquid water. This water would have percolated through the rock for millions of years, reacting with it, transforming it, creating the very clay minerals that OSIRIS-REx was now detecting. This parent body was a dynamic, geologically active, water-rich world. Then, at some point in the distant past, a catastrophic event occurred. This magnificent water world was shattered in a colossal impact with another large object. The solar system was a violent place, then a cosmic billiards table of colliding worlds. From that cataclysm, countless fragments were thrown out into space. Bennu is one of those fragments. It is like finding a single water-stained brick in the middle of a desert. The brick itself is dry, but its stains tell you it came from a place of rain and moisture. Bennu is our water-stained brick from a lost primordial cathedral. It is a direct physical link to a kind of world that may no longer exist in our solar system, a world that could have been a crucible for the chemical reactions that lead to life. This discovery elevated the importance of the mission immensely. OSIRIS-REx was not just going to collect a rock. It was going to collect a piece of a lost watery world. It was going to sample the memory of water itself, and as if this profound echo from the past were not enough, Bennu had another surprise in store, a sign that it was not as dormant as it appeared. While the spacecraft was diligently mapping the surface, its navigation cameras began to spot something strange. Tiny flecks of light moving away from the asteroid. At first, they were dismissed as cosmic rays or digital noise, but the sightings persisted. The team soon confirmed the unbelievable Bennu was actively shedding parts of itself into space. They witnessed dozens of these particle ejection events. Small clouds of dust and pebbles, some as large as a few centimeters, were being flung from the surface. Some particles shot off into space, escaping Bennu's feeble gravity forever. Others remarkably went into a temporary orbit, becoming tiny short-lived moons of Bennu, before spiraling back down to the surface days or weeks later. OSIRIS-REx found itself flying through a miniature intermittent meteor shower of Bennu's own making. This was a shocking discovery. Small inactive asteroids were supposed to be just that, inactive. They were thought to be geologically dead. But Bennu was alive in its own subtle, quiet way. What could be causing this? Scientists proposed several possibilities working together. The intense heating and cooling of rocks during Bennu's short 4-hour day could cause thermal fracturing, making rocks crack and shed material. The rapid spin could be flinging loose pebbles from the equator, and the constant rain of tiny micrometeoroids too small to see could be kicking up dust like tiny impact grenades. Whatever the cause, the discovery was transformative. It painted a picture of Bennu not as a static museum piece, but as a dynamic, evolving world. Imagine watching a great ancient statue that you believe to be perfectly still, and then seeing it shed a single tear of dust. It changes your entire perception. Bennu was not just a relic of the past. It was a living artifact, still interacting with its environment, still changing, still breathing out tiny pieces of itself into the void. These two discoveries, made while orbiting from a safe distance, fundamentally changed the context of the mission. The team now knew they were orbiting a fragment of an ancient water world that was still in some mysterious way active. The desire to collect a sample became an overwhelming scientific imperative. To get a piece of those hydrated clays into a laboratory on Earth would be to open a chapter of solar system history that had been sealed for billions of years. It could provide clues to one of the greatest mysteries of all, how Earth, which formed in a dry part of the solar system, came to have its vast, life-giving oceans. Perhaps they were delivered by countless impacts from water-rich asteroids, just like Bennu's parent body. And so the search for a landing site took on a new urgency and a new meaning. It was not just a search for a safe place. It became a search for a scientifically priceless place, a place where these precious water-bearing clays were abundant and accessible. The echoes of lost water had made Bennu's whispered song an irresistible siren call. The team now knew with more certainty than ever that they had to find a way to touch this world, no matter how rugged, no matter how risky. They had to answer the call of that ancient watery ghost. The maps were drawn, the secrets of ancient water had been heard, and the 4 tiny hopeful candidates for contact had been chosen. After months of intense deliberation, weighing the scientific promise against the terrifying risks, the team made its final choice. The destination for the most critical moment of the entire mission would be a site named Nightingale. Nightingale was a small clearing, no bigger than a handful of parking spaces, located within a larger younger crater near Bennu's northern pole. Its youth was its greatest appeal. A more recent impact had carved out this crater, exposing fresh material from beneath the surface material that had been shielded for millennia from the harsh radiation of space. It was like opening a book to a fresh, unyellowed page, but this promise came with a formidable threat. On the crater's rim loomed a colossal boulder, a monolith the size of a building that the team grimly nicknamed Mount Doom. If the spacecraft's descent was off by even a few meters, it would be dashed against this rock. The choice was made. The potential reward of pristine, unweathered material was worth the high-stakes gamble. But one does not simply descend upon such a place. The team and the spacecraft had to practice. They began a series of rehearsals, each one a step closer to the final performance. Think of it as a diver practicing from progressively higher platforms before attempting the final record-breaking plunge. The first major rehearsal, called Checkpoint, saw OSIRIS-REx descend to a mere 75 meters above Nightingale. From this vantage point, it scanned the surface, its navigation systems memorizing the landscape of boulders, matching what it saw in real time to the detailed maps stored in its memory. This was a critical test of its autonomous brain, its ability to know exactly where it was in relation to the target. After hovering for a few minutes, a lifetime in mission terms, it fired its thrusters and retreated. The test was flawless. Weeks later came the second and final dress rehearsal, Matchpoint. This time the spacecraft descended even further to a breathtaking altitude of just 40 meters. It was now closer to the surface of Bennu than the top of a 10-story buildings to the ground. It followed the entire descent path, performed all the crucial pre-landing maneuvers, and came to a hover directly above the target site. It was so close that if it had a human pilot, they could have seen the individual pebbles on the ground. This was the final exam before the day of the test itself. It tested every sequence, every calculation, every system, stopping just short of the final extension of its arm. Once again, it performed perfectly before backing away. The archer had practiced their aim. The diver had perfected their form. The stage was set. Then on October 20th, 2020, the day arrived. A hush fell over the Mission Control Center on Earth, a unique silence woven from anticipation, hope, and sheer terror. For the next several hours, the fate of the mission was entirely out of their hands. The distance to Bennu was so great that it took radio signals over 18 minutes to travel one way. Real-time control was impossible. OSIRIS-REx was on its own. It would follow a preloaded sequence of commands, a complex and beautiful choreography programmed by its creators, and it would succeed or fail based on its own robotic wits. The descent began. It was not a fiery plunge, but a slow, stately 4-hour fall. The spacecraft was not so much flying as it was guiding its own descent, with tiny, precise puffs from its thrusters, gently braking against the faint but persistent pull of Bennu's gravity. It was a ballet of patience. As it descended, it transformed itself. Its large wing-like solar panels, which normally lay flat to catch the sun, began to move. They rotated upwards into a distinctive Y-wing configuration. This served two crucial purposes. First, it would lift the delicate panels away from the surface during the moment of contact, protecting them from any dust that would inevitably be kicked up. Second, it provided more stability and ground clearance, a small but vital insurance policy in case the spacecraft tipped slightly upon touching the uneven ground. It was an act of robotic self-preservation, a cautious hunching of the shoulders before a delicate task. The spacecraft's arm, the touch-and-go sample acquisition mechanism, or TAGSAM, was already extended. It was a long, articulated limb, and at its end was the collection head, the hand that would perform the touch. The entire mission, the billions of kilometers traveled. The years of planning had all been distilled into the next few minutes, and the success of it all rested on this one gentle contact. On Earth, the team watched the data stream in 18 minutes old. They were watching a ghost, seeing the spacecraft's actions as they had already happened. They saw it pass the checkpoint altitude. They saw it pass the match point altitude. Everything was proceeding exactly as rehearsed. It was a slow, agonizing, perfect descent. Then came the moment of contact. The spacecraft's arm reached out, aiming for the small clear patch within Nightingale. The expectation was for a gentle bump, a slight crunch as the sampler head made contact with a surface of loose gravel and pebbles. What happened next was something no one had fully anticipated. There was no bump. There was no crunch. The arm touched the surface, and it simply kept going. It sank. The surface of Bennu was not solid. It was an ethereal, barely there substance, a loose pile of material with an incredible amount of empty space between its particles. The resistance was almost zero. The sampler head and a good portion of the arm plunged nearly half a meter into the asteroid. It was like stepping onto what you believe is a solid stone path, only to find it is a deep, soft drift of black snow. It was like plunging your hand into a pit of foam balls. Bennu was not a rock. It was a cosmic illusion of solidity. For a heart-stopping second, the spacecraft, a machine weighing over a ton, was being swallowed by this fragile world. But its programming was flawless. As the arm sank, a sensor detected the contact, and the most critical action of the sequence was triggered. A bottle of pure high-pressure nitrogen gas was released. For 3 seconds, a powerful burst of this gas shot out from nozzles in the sampler head directly into the loose material it was now buried in. It was a targeted underground explosion of air. Imagine blowing as hard as you can through a straw into a deep pile of flour. The purpose was to fluidize the regolith, to violently churn the dust and pebbles of Bennu's surface, creating a turbulent cloud of ancient matter. The design of the sampler head was meant to funnel a portion of this chaotic cloud into its collection chamber. The entire contact on the surface lasted for just 6 seconds. 6 seconds of sinking, firing, and collecting. Then, as programmed, the spacecraft's backaway thrusters fired, pushing it powerfully away from the surface. The images it sent back in the moments after it retreated were breathtaking. The gentle touch had been anything but. OSIRIS-REx had not just created a small divot, it had blasted a new crater into the side of Bennu, a gaping hole over 8 meters across. The surface had behaved like a fluid. Boulders the size of small refrigerators were thrown dozens of meters. The ground itself seemed to have liquefied and flowed away from the point of contact. The spacecraft had punched a hole in the void. It was a stunning visceral demonstration of just how delicate, how fragile, and how loosely held together this ancient world truly was. OSIRIS-REx was now a safe distance away, coasting slowly from the expanding, glittering cloud of debris it had created. The maneuver, as a feat of engineering and autonomous navigation, was a staggering success. The team on Earth erupted in a wave of cheers, relief, and joyous tears. They had done it. They had successfully touched an asteroid and pushed away. But in the quiet moments after the celebration, a new critical question began to fill the air. The most important question of all. Did it work? Was there anything inside the sampler head? The arm had sunk deeper than expected. The surface had behaved in a way no one had predicted. Had it collected the 60 grams of material that was the mission's goal? Had it collected anything at all? Or was the collection chamber empty? The spacecraft was now a messenger with a sealed letter in its hand. But no one, not the team on Earth, not the spacecraft itself yet, knew what, if anything, was written inside. The gentle touch was over, leaving a dramatic scar on a 4.5 billion-year-old face, and the mission now hung in a state of profound and hopeful suspense. The spacecraft OSIRIS-REx drifted in the silent aftermath of its own dramatic creation. The scar on Bennu's surface was a fresh and startling wound, and the cloud of liberated dust glittered in the sun, a transient nebula of ancient matter. On Earth, the initial wave of elation at the successful touchdown gave way to a quiet, gnawing suspense. The most important question remained unanswered. Had the gentle touch yielded a harvest? Was there anything in the hand of their robotic messenger? There was no simple way to know. The collection head was sealed, or so they hoped, and there were no windows to peer inside. To find the answer, the team on Earth initiated one of the mission's most elegant and clever procedures, a maneuver designed to weigh the sample using the entire spacecraft as a cosmic scale. The plan was the spacecraft would fully extend its long sampling arm, the tagsum holding the collector head out at a distance. Then it would use its thrusters to initiate a slow, controlled spin. By measuring the precise amount of thrust needed to start and stop this rotation, and the time it took to complete the maneuver, scientists could calculate the spacecraft's change in its moment of inertia. It is a principle we understand intuitively here on Earth. Imagine holding a long stick and swinging it. Now imagine tying a small rock to the end of that stick and swinging it again. You can feel the difference. The stick with the rock is more resistant to being moved. It has more inertia. By measuring that change in resistance, you can get a sense of how heavy the rock is. OSIRIS-REx was about to perform this exact experiment. It was going to swing its arm and feel the weight of its catch across a distance of over 300 million kilometers. The maneuver was executed with robotic grace. The data flowed back across the intervening gulf of space, was collected by the Deep Space Network, and processed by the computers at Mission Control. The team huddled around their screens, waiting for the numbers that would tell them if their 7-year journey had been a success. The goal for the entire mission was to collect a minimum of 60 grams of material, a little over 2 ounces, about the weight of a small bag of chips. They were hoping they had at least met that benchmark. The results that came back were stunning. They were unbelievable. The calculations showed not 60 grams, but a colossal amount of material. The official estimate was that the head contained at least 400 grams, and perhaps well over a kilogram, more than 2 pounds, of pristine 4.5 billion-year-old asteroid. The deep half-meter plunge into Bennu's unexpectedly soft surface had worked better than anyone had ever dreamed. The spacecraft had not just scraped the surface. It had taken a giant core sample. It had a treasure trove, a bounty of cosmic history that would keep scientists busy for decades. A new wave of celebration, even more joyous than the first, erupted. They had done it, and they had succeeded beyond their wildest imaginations. But in the world of space exploration, triumph and terror often walk hand in hand. As the team celebrated their monumental success, another group of engineers was carefully analyzing the images the spacecraft was taking of the sampler head itself, just to get a visual confirmation of the hardware's condition. And they saw something that made their hearts stop. The images were surreal, beautiful, and deeply alarming. The mylar flap that was designed to act as a lid to seal the collected material inside the head was not fully closed. It was jammed partially open, propped up by a few pebbles that were slightly too large to fit inside. And from the small gap, a steady glittering stream of dark particles was escaping into space. They were watching their priceless treasure leak away. Each tiny speck of dust that floated away from the collector head, glinting for a moment in the harsh sunlight, before vanishing into the black, was an irreplaceable piece of scientific data. It was a word from the book of primordial history, lost forever. The very success of the collection, The sheer volume of material had become its greatest threat. They had collected so much that it was now spilling out a cosmic treasure chest with a broken latch, trickling gold coins into an infinite ocean. The mood at Mission Control shifted instantly from elation to a focused, urgent intensity. The original mission timeline was leisurely. It had planned for several more weeks of observations and maneuvers, including the spin test, to weigh the sample, which ironically had now confirmed just how much they were losing. That entire plan was thrown out the window in an instant. This was now an emergency. It was a race against time to stop the leak. The only way to do that was to stow the sampler head into its secure transport vessel, the Sample Return Capsule, or SRC, as quickly as was humanly and robotically possible. What followed was a frantic around-the-clock effort. Engineers and scientists who had been working for years on this mission gave up sleep working with a singular focus. They had to rewrite, test, and upload a complex multi-day robotic sequence in a matter of hours. Every command had to be perfect. One wrong move, one incorrect calculation, and they could damage the arm, the capsule, or even lose the entire sampler head into the void. It was a high-pressure, remote-controlled surgery on a patient hundreds of millions of kilometers away. The stowing sequence began. It was a slow, deliberate robotic ballet, each movement imbued with a breathtaking tension. First, the spacecraft's cameras had to get one last good look to give the team on Earth the visual information they needed to guide the process. Then the tagsome arm holding the leaky collector head began to move. It maneuvered with excruciating slowness toward the main body of the spacecraft, where the Sample Return Capsule, a disc-shaped vessel looking like a futuristic flying saucer, lay open and waiting. Imagine trying to thread a needle from across a city using only a set of remote-controlled robotic arms, where every command you send takes 18 minutes to arrive. The precision required was almost unimaginable. The arm had to perfectly align the collector head with the capture ring inside the SRC. With agonizing care, it moved the head into place. The team on Earth watched their telemetry, their hearts in their throats. They saw the confirmation that the head was seated correctly. A command was sent to fire the latches. A tense 18-minute wait. Then the confirmation the latches were engaged. The collector head was locked securely inside the capsule, but it was still attached to the arm. The final step was one of irreversible commitment. A command was sent to activate a cutting mechanism which severed the tube connecting the head to the rest of the arm. A sharp, silent severing. The collector head, with its priceless overflowing bounty of Bennu, was now free from the arm that had carried it. The tagsome arm, its primary job now complete, slowly retracted empty for the first time since it was built. Finally, a command was sent to close the lid of the Sample Return Capsule itself, sealing the treasure within 2 layers of protection. The leak was stopped. The treasure was safe. A collective sigh of relief so profound it felt physical swept through Mission Control. They had faced an unexpected crisis and had overcome it with speed, ingenuity, and grace under pressure. Some material had been lost, perhaps tens of grams, but they were confident that a massive sample far exceeding the mission's original goals was now safely tucked away for its long journey home. The character of the mission had changed one last time. OSIRIS-REx was no longer a mapper, a surveyor, or even a collector. Its work at Bennu was done. It was now a guardian. It was a courier entrusted with the most precious cargo imaginable, a handful of the void, a piece of a lost water world, a physical link to the dawn of our solar system. Its final task was to turn away from the spinning diamond it had come to know so well and begin the long, slow journey back to the blue and distant world that had sent it on its quest. The treasure was secure. The frantic, delicate surgery to stow the overflowing sample was complete. A profound sense of accomplishment settled over the mission, a quiet breath taken after a long and perilous climb. For over 2 years, OSIRIS-REx had made its home in the gravitational embrace of this tiny spinning world. It had learned its shape, mapped its rugged face, listened to its secrets of ancient water, and felt its surprisingly soft surface. But its work here was finished. The time had come to leave. A departure, like an arrival, is not a simple single event. Before turning its back on Bennu forever, the spacecraft performed one final poignant act of observation. It did not speed away immediately. Instead, it embarked on a last slow farewell flyby, arcing gracefully around the asteroid one more time. This was not for sentiment, but for science and for closure. Its cameras turned toward the northern pole, toward the Nightingale crater, to look upon the place of their historic encounter. The images it sent back were a stark and beautiful testament to the interaction. There on the dark surface was a massive, fresh wound. The place where the sampler had touched down was now the site of a gaping new crater. The ground was visibly disturbed with bright, newly exposed material, creating a halo around the point of contact. Most dramatically, a huge boulder weighing over a ton that had been sitting near the edge of the collection site had been thrown a full 12 meters by the force of the gas ejection and the thruster fire. The spacecraft had not just touched Bennu, it had reshaped it. It had left its own indelible mark on this 4.5 billion-year-old world. Taking this final portrait was like an artist stepping back to gaze upon their finished work, a mixture of awe at the effect and a quiet reverence for the canvas. It was a final look, a respectful nod, a last goodbye. Then in May of 2021, the journey home began in earnest. There was no thunderous roar, no violent blast of propulsion. Leaving Bennu's faint gravitational hold required a far more delicate touch. For 7 days, the spacecraft's main thrusters fired in a long, slow, sustained burn, gently but persistently, nudging the spacecraft away from the asteroid. It was not like a rocket launching from a planet. It was more like a small boat pushing away from a wooden dock. The ropes are untied, and a gentle push is all that is needed to begin drifting to slowly sever the last ties that bind you to the shore. With each passing moment of the burn, Bennu's hold grew weaker until finally OSIRIS-REx broke free. It was once again a solitary traveler in the deep, but this time it was not on a mission of discovery. It was on a mission of delivery. The long road home began another 2-year drift through the silent, sunlit void. The journey mirrored the outbound voyage in its vastness and its quiet, but its character was fundamentally different. On the way to Bennu, the spacecraft was a probe, an empty hand reaching out filled with questions and potential. Now it was a courier, a guardian. It was a vessel whose entire purpose had been distilled down to one single overriding priority: to protect the precious cargo sealed within its heart. This cargo, the sample return capsule, was now the soul of the machine. The spacecraft was its life support system, its armored transport. Its solar panels drank in the sunlight, not for its own exploration, but to power the systems that would ensure the capsule's safe passage. Its thrusters fired not to seek a new destination, but to keep it true on its long arcing path back to Earth. Let us imagine the spacecraft as a celestial Fabergé egg, a creation of exquisite and complex engineering, whose every gear and circuit is designed solely to protect the priceless jewel hidden inside. The jewel in this case is not made of diamond and gold, but of something far more valuable: carbonaceous dust, rock, and time. It is a handful of the void, a concentrated piece of the dawn of our solar system. And let us also reflect, as we drift alongside this guardian on the journey of the sample itself. The tiny particles of dust and rock resting inside the capsule have been on an odyssey far grander and more ancient than that of the machine carrying them. Their story did not begin with the launch of a rocket from Florida. Their story began before there was an Earth to launch from. These grains were born in the vast, cold, swirling cloud of gas and dust that predated our sun. They were witness to the ignition of our star. They coalesced and became part of the great water-rich parent body, the lost primordial world we can now only imagine. They felt the warmth of its interior, were bathed in the liquid water that transformed them into clays. They survived the cataclysmic impact that shattered their world, being thrown into the cold, dark emptiness of space. For billions of years, they drifted as part of the rubble pile we call Bennu, spinning in the sunlight, enduring the constant rain of micrometeoroids, holding on to their chemical memory of a watery past. Now, after 4.5 billion years of drifting through the solar system, their journey is entering its final, most improbable chapter. They are being carried in a climate-controlled, perfectly sealed vessel to a world they could never have reached on their own. The journey of OSIRIS-REx is but the final fleeting leg of the sample's own immense pilgrimage through time. The spacecraft is not just carrying a rock, it is carrying a story, and the story's main character is the sample itself. The 2 years of the return journey passed in the same profound silence as the trip out. The sun was a constant companion, the stars a steady, unblinking audience. But this time, the view ahead was different. On the way out, the blue marble of Earth had shrunk, becoming a memory, a point of origin. Now that same blue marble was the destination. Slowly, almost imperceptibly at first, a single point of light ahead began to distinguish itself from the stars. It shone with a familiar gentle blue. As weeks turned into months, the point of light grew. It became a disk, a crescent, a world. The continents and oceans of our home began to resolve out of the blackness. The feeling on board the spacecraft, or at least in the hearts of the team guiding it, was not one of outward-bound exploration, but of homecoming. The messenger was nearing the end of its route. The courier was approaching its final delivery address. The scale of the journey is almost too vast to hold in the mind. A round trip of over 6 billion kilometers, all to retrieve a handful of dust. It is a testament to the immense value we place on knowledge, on understanding our own story. We are a species that will build a machine of breathtaking complexity, send it on a 7-year journey across the solar system to touch a world it can barely hold on to with gravity, all to answer a question that sparked in a curious mind. Where did we come from? As the 2nd year of its return journey drew to a close, the spacecraft began its final approach. Earth loomed large now, a vibrant living world filling the view. The long quiet drift was almost over. The mission of the OSIRIS-REx spacecraft itself was nearing its end. But its legacy, the reason for its entire existence, was just about to begin. The courier was preparing to hand over its letter. The final dramatic act of this celestial ballet, the fiery plunge and the soft landing, was imminent. The long silent journey home is over. The spacecraft OSIRIS-REx now approaches the bright blue-white world of its birth. Not as a returning resident, but as a passing courier making its final, most important delivery. Its 7-year odyssey across billions of kilometers of space is about to culminate in a final 13-minute cascade of fire and grace. The day is September 24th, 2023. On its final approach, the spacecraft does not slow down to enter Earth's orbit. Its momentum is too great, its purpose too specific. Instead, it lines itself up with a precise invisible corridor in the sky, a pathway aimed at the heart of the Utah desert. At a distance of just over 100,000 kilometers from the surface, about a third of the way to the moon, the moment of separation arrives. With a final gentle command from its distant creators, the spacecraft executes its last primary task. A series of small mechanisms release their hold, and the sample return capsule, the precious vessel containing the dust of Bennu, springs away from its mothership. It is a quiet, unassuming act of release, like a bird letting go of a single precious seed from a great height. For a moment, the two objects drift together, the larger guardian and the small coasting child. Then the OSIRIS-REx mothership fires its main thrusters, a powerful and decisive burn that pushes it away from Earth, diverting its path to avoid its own fiery demise. Its job as a guardian is over. As it veers off into the deep, beginning a new journey and a new life, it leaves its precious cargo to complete the final perilous plunge alone. The capsule is now a solitary traveler pulled inexorably forward by the familiar powerful force of Earth's gravity. It is aimed with breathtaking accuracy at a specific patch of desert, but its path is now unchangeable. It is a ballistic object, a bullet fired from the edge of space. For 4 hours it falls accelerating constantly, a silent, unseen projectile aimed at the top of our atmosphere. Then it hits. It crosses that invisible boundary where space ends and sky begins. The first tenuous molecules of the upper atmosphere brush against its heat shield, and in that instant, the laws of physics ignite in a display of awesome and terrible power. The capsule is traveling at over 44,000 kilometers per hour, more than 12 kilometers every second. At this speed, the air in front of it cannot get out of the way. It is compressed almost instantaneously into a brilliant incandescent sheath of plasma. The temperature skyrockets to nearly 3,000 degrees Celsius, a heat half as intense as the surface of the sun. The capsule has become a man-made meteor, a falling star with a purpose. For those on the ground lucky enough to see it, it is a brilliant streak of light tearing across the morning sky, a fiery teardrop shed by the heavens. It is the second fastest object ever built by human hands to return to our world, a testament to the immense energies involved in interplanetary travel. Inside the capsule, experiences forces of over 32 Gs, an acceleration that would crush any human occupant into dust. But the capsule was built for this. It was born for this fire. Its survival depends entirely on its shield, a masterpiece of material science called EPCE, or phenolic impregnated carbon ablator. This is not a shield of strength, but a shield of sacrifice. It is designed to burn. As the superheated plasma engulfs the capsule, the outer layers of the shield begin to char, melt, and vaporize. This process, called ablation, is a kind of controlled disintegration. The vaporizing material creates a boundary layer of gas that pushes the worst of the heat away from the capsule. The shield sheds its own substance layer by fiery layer, carrying the searing heat of re-entry away with it. It is a heroic act of self-destruction, and it works perfectly. While the outside of the capsule is a raging inferno, the precious sample of Bennu nestled deep inside its core remains cool and safe, never experiencing a temperature warmer than a pleasant summer day. This trial by fire, the moment of peak heating and maximum deceleration, lasts for only a few minutes. Having shed the vast majority of its cosmic velocity as heat and light, the capsule is now deep within the atmosphere, tumbling through the stratosphere. The violence is over. The next phase is one of control and grace. At an altitude of about 30 kilometers, a small mortar fires, deploying the first of 2 parachutes. This is the drogue chute, a small tough parachute not designed to stop the capsule, but simply to stabilize it. It rights the capsule from its tumble, positioning it heat shield down, and prepares it for the main event. The capsule continues to fall, but it is now orderly, no longer a chaotic projectile. Then, at about 1.6 kilometers from the ground, the main parachute is released. It blossoms open in the desert sky, a huge canopy of orange and white, and in that moment, the entire character of the descent changes. The capsule, which moments before was a plummeting object of immense speed and energy, is now a gently floating package. It is as if the mission has taken a long, deep, calming breath. The great orange and white flower catches the desert wind, and the capsule's speed slows to a leisurely 18 kilometers per hour, about the pace of a gentle bicycle ride. In helicopters circling nearby, the recovery team watches the final moments of this 7-year journey. They have been tracking the capsule on radar since it was a fiery streak high in the sky. Now they have a visual. They can see it, a small dark object swinging gently beneath its huge, beautiful parachute, descending toward the designated landing zone within the Utah Test and Training Range. The years of planning, the months of rehearsals, all come down to this final, gentle return to Earth. And then, with a soft thud that is lost in the vastness of the desert, it touches down. 13 minutes after it first pierced the atmosphere, as a blazing star, the sample return capsule comes to rest on the pale, sandy soil of the Utah desert. It sits upright, slightly askew, its parachute pooled beside it like a discarded flower. It is a surreal sight, a piece of deep space technology scorched black and scarred by its passage through fire, now sitting quietly under a blue terrestrial sky. A piece of the cosmos, a messenger from a 4.5 billion-year-old world, has come home. The helicopters land a safe distance away, and the recovery team moves in. Their efficiency is born of long practice. Every second counts now. Their goal is to retrieve the capsule as quickly as possible to protect its pristine cargo from the slightest contamination by Earth's environment. Dressed in protective gear, they approach the capsule with a quiet sense of reverence. They are the first human beings to stand in the presence of this primordial material, separated only by a few layers of metal and heat shield. They perform a quick survey, ensuring the capsule is intact and safe to approach. Then, with great care, they place it into a specialized cradle, lift it, and carry it to a waiting helicopter. It is flown immediately to a temporary clean room that has been set up nearby in a hangar. The first part of its terrestrial journey is complete. The 7-year voyage through the vacuum of space is over. The perilous fiery plunge through the atmosphere has been survived. The sample, the entire reason for this grand endeavor, is now safe and sound on Earth. The promise made so many years ago has been fulfilled. The letter carried across an impossible distance has been delivered. It now sits in a clean room in the Utah desert waiting. All that is left to do is to open it and to read the secrets it holds. The journey through the fire is complete. The journey through the heavens is over. But the final, most delicate journey for the Bennu sample has just begun. It is a terrestrial journey from the dusty plains of Utah to a sanctuary of science in Houston, Texas. The sample return capsule, having endured the extremes of space and re-entry, is flown with the care afforded to a head of state to NASA's Johnson Space Center. It is destined for a specially built curation facility, a place that is arguably one of the cleanest, most carefully controlled rooms on the entire planet. Here in this inner sanctum, the process of unlocking the time capsule begins. But it is a process of almost unimaginable care. The greatest threat to this 4.5 billion-year-old material is no longer the vacuum of space or the heat of re-entry. The greatest threat is now the Earth itself. Our planet's atmosphere, the very air we breathe, is a corrosive fog of oxygen and water vapor to these pristine minerals. To expose them to it would be to instantly alter their ancient chemistry, to smudge the ink of the letter before it could be read, and so the scientists must protect the sample from our world. All the work is done inside a specially designed glove box. This is not the simple box you might imagine. It is a hermetically sealed container, a sterile world within a world, constantly flushed with a gentle flow of pure nitrogen gas. Nitrogen is inert. It does not react with the sample, and so it preserves its pristine state. The scientists do not touch the sample directly. They place their hands into thick built-in gloves, reaching into this miniature nitrogen-filled world to perform their delicate work. In a beautiful reversal of roles, it is the scientists who are now in the spacesuit, and it is the alien material that is in its native protected environment. The first step is to open the outer shell of the capsule, the part that bore the brunt of the fiery descent. As they do, they are greeted with their first gift, a bonus sample. A fine coating of black dust and small pebbles covers the exterior of the inner collection mechanism. This is the material that had leaked from the jammed sampler head, a beautiful, messy consequence of their overwhelming success. This dust, carefully collected with brushes and scoops, provides the very first look at Bennu's substance, and it is a marvel. Darker than charcoal, rich and crumbly, it is a scientist's dream. But the main prize, the core sample, is still locked away inside the TAGSIM head. The team begins the final disassembly, carefully removing the 35 fasteners that hold the lid in place. 33 of them come off without issue. But 2 of them, 2 tiny screws, refuse to budge. They are stuck fast. It is the final ironic challenge of this long journey. After traveling across the solar system, after navigating a world of boulders, after surviving a plunge through fire, the mission is stalled by two stubborn screws. The reason the dust from Bennu itself, so fine and pervasive, has worked its way into the threads, jamming the mechanism. The asteroid, it seems, is reluctant to give up its final secrets. There are no existing tools in the pristine glove box that can be used to safely remove them. To bring in a standard tool from a hardware store would be to introduce a flood of contaminants. And so, the mission team must solve one last engineering puzzle. They must design, fabricate, and test entirely new tools, custom-made from a specific grade of surgical non-magnetic stainless steel, certified to be clean enough to enter the sacred space of the glove box. It is a microcosm of the entire mission, a challenge met with patience, ingenuity, and an unwavering commitment to preserving the integrity of the science. Months pass in this painstaking work. Finally, with the new custom-made screwdrivers in hand, the team reaches through the gloves and with infinite care turns the final two fasteners. They give way. The last latch is released. The lid of the TAGSAM head is lifted. And there it is. For the first time, human eyes look upon the pristine, untouched core of a 4.5 billion-year-old world. It is not a glittering pile of jewels. It is a small mound of dark, crumbly rock and dust. It looks perhaps like a scoop of rich, dark soil from a cosmic garden. But to the people looking on, it is the most beautiful sight in the universe. It is the finish line. It is the treasure. It is the answer. The total sample is weighed and cataloged. Over 121 grams, more than twice the mission's goal. It is an extraordinary success, a bounty that will fuel scientific discovery for generations to come. And so we finally begin to read the letter we have traveled so far to collect. What does it say? What stories are held within this handful of dark dust? The initial findings are more profound than anyone had hoped. The sample is confirmed to be incredibly rich in carbon, the very backbone of life as we know it. And it is teeming with organic compounds. Not life itself, but the chemical precursors to it. It is as if we have found the orchestra's instruments, the notes and scales from which the symphony of life can be composed. And then there is the water. The sample is dominated by those water-bearing clay minerals, the chemical ghosts of Bennu's parent body. The evidence is overwhelming. Bennu is indeed a fragment of a lost world that was once soaked in liquid water. And even more startlingly, scientists find phosphates in the sample. Phosphates are a crucial component of DNA of the very molecule that carries the blueprint for life on Earth. To find water-soluble phosphates in this sample suggests that Bennu's ancestor was not just a wet world, but a world with a rich complex chemistry, an environment startlingly similar to the one in which life may have first emerged on our own primitive Earth. They find tiny microscopic crystals called pre-solar grain specks of stardust that are older than our sun. These grains were forged in the hearts of long-dead ancient stars and were scattered across the galaxy, eventually becoming part of the nebula from which our own solar system formed. To hold one of these in a lab is to touch a messenger from a time before our time, a physical relic from a star that died so that our sun could be born. This is the legacy of OSIRIS-REx, but it is a legacy that is just beginning. The vast majority of the Bennu sample, over 70%, will be carefully preserved in the nitrogen-filled vaults in Houston. It is a gift to the future. It will be saved for generations of scientists yet to be born who will approach it with new technologies we cannot yet imagine and ask questions we do not yet know how to ask. The remaining portion is being carefully divided and sent to hundreds of scientists in laboratories all around the world, a global collaboration to decipher the secrets of our shared past. And what of the messenger itself? The OSIRIS-REx spacecraft, its primary mission complete, was not retired. Now renamed OSIRIS-APEX, it is already on its way to a new target, a different kind of asteroid named Apophis. Its journey of exploration continues, a testament to the enduring spirit of curiosity that first sent it on its way. So now our own journey comes to a close. We have traveled from a quiet question to a handful of cosmic dust resting in a laboratory on Earth. we have seen that the story of a distant dark asteroid is also the story of our own world. The carbon in that sample is the same carbon that flows through our veins. The memory of water locked in its clays tells the story of the water that fills our oceans and gives us life. We are, in the most literal sense, made of the same stardust. The next time you find yourself under a dark, clear sky, let your gaze drift upwards. See the stars not as distant cold points of light, but as relatives. See the darkness between them, not as emptiness, but as a space filled with history, with memory, and with countless other messengers carrying stories we have not yet learned to read. The great voyage of OSIRIS-REx is over, but our human voyage of wonder has only just begun. Rest now in the quiet knowledge that you are connected to it all. You are home in a universe far more intimate and wondrous than you could ever imagine.